All right, so now it's time to work with your partner, and we're going to spend 12 minutes looking at a couple of problems. What the problems I want you to look at are number 4 and number 6. In the interest of time, we're going to skip number 5. Now, I do want you to use your algorithm to divide these fractions. So what does that mean? Let me get you started on number 4. Here's what we want you to do. You have 5 2/3 pounds of trail mix. How many bags can you make so that each bag has 1 5/6 pounds? 1 5/6 pounds. This is a division problem. Now I know that you could draw a bar model. I know that you could draw a number line, but I don't want you to because it would take a long time. Instead, what I want you to use is the algorithm. So I want you to change these into improper fractions. There we go. And I want you to rewrite this division problem as multiplication and solve it. So here you would do 17/3 times the reciprocal of 11/6. So times 6/11. That's what I want you to do. I want you to use that process. Now, I got this one set up for you. It is ready to go. You are ready to multiply. This is going to be easy. The next one, I want you to set up by yourself. So that means I want you to change those mixed numbers to improper fractions, and I want you to rewrite the division problem as multiplication by the reciprocal of the divisor. You can do it. Work with a partner. We're going to use 4 minutes for each question. So you have a total of 8 minutes to do these two problems. Set a timer for 8 minutes. Pause the video, and we'll work together more in just a little bit. Well, you've done some excellent work with fractions with your partners and with your groups. Let's look today at some different strategies that you can use to divide fractions. So far, we've used bar models, we've used number line models, and we've used an algorithm in which we multiply by the reciprocal of the divisor instead of dividing. But this is just neat to know. In the same way that when we multiply fractions, we multiply across, we can actually divide fractions by dividing across. Check it out. Here's an example. If we wanted to do 7/8 divided by 1/2, we could actually just do 7 divided by 1 and 8 divided by 2. The answer is 7/4, and that's correct. Here, let me demonstrate it. It gives me the same result that I would get if I multiplied by the reciprocal of the divisor. See, I would get 7 times 2 is 14. 14/8, and then that would simplify to give me 7/4. So why don't we just do that all the time? Well, let's explore. Maybe we want to. Here's some examples. Try dividing across to get each quotient. Pause the video, set a timer for 6 minutes, and try this out with your partner. Can you divide across on all 4 of these problems? If you can, why? If you can't, why not? Well, if you're hitting play, you're ready to talk about this. And looking at these, A was pretty easy. 3 divided by 1 was 3, and 8 divided by 4 was 2. That's 3/2 or 1 1/2. B was pretty easy. C was pretty easy. But what about D? In our numerator, we had 1 divided by 3. In our denominator, we had 4 divided by 4. But what are we supposed to do with that? Well, we could just write it like this, 1/3 in our numerator and 1 in our denominator. That's right. It's just kind of strange. So what was special about A, B, and C that made it a very easy strategy just to divide across? Well, we were able to divide across without getting any remainders. That's what made A, B, and C so easy. That didn't work here with D because 1 divided by 3 is 1/3. D is definitely not wrong. It still works. The answer to this, 1/3/1, is just 1/3, and we can leave it like that. It's just something to keep in mind. This strategy mostly works when we have numbers that play nice together. Look at these numbers that Kareem is using. He is trying to divide across using that strategy with 6/7 divided by 2/3. He's got the 6 divided by 2 part. 6 divided by 2 is 3. And in the bottom, he's got 7 divided by 3. Well, 7 doesn't go into 3 evenly. There's a remainder. So what can he do? Stella is trying to help him, and this is what she said. She said, well, this is still a fraction. I know that 3 divided by 3 is 1. So, you know what? I think the answer is 1/7. But here's a hint, guys. Stella is not correct. What's wrong with Stella's reasoning? Take a minute to think about it. The problem with Stella's reasoning is that she is treating these 3's as if they are common factors to the numerator and the denominator. But in fact, that's not the case here, because 3 is actually part of a quotient in the denominator. Now here's what Catherine said. Catherine's reasoning might seem more complicated, but it is correct. She said, we know how to rewrite a division sentence as a fraction. So we have 3/7 divided by 3, but we could write it like this. We could write it as 3/7/3. I'm making my bar in the middle a little bit bigger to make that easier to understand. We also want the denominator to be 1, so we need to use some multiplicative inverses. So what does that mean? Well, I have 3/7/3. And what's my reciprocal of 7/3? 3/7. These are reciprocals. So what we're going to do here is multiply both the numerator and the denominator by 3/7. And when we do that, we end up with 1 in our denominator, and we end up with 3 times 3/7 in our numerator. Whew, Catherine, this is a little bit of a confusing answer, but you are correct. 3 times 3/7 is 9/7, and so that's what the answer would be. Guys, in this case, dividing across didn't make it easier. So that's why we don't usually use that strategy, but you can use it. It is a correct strategy. You can divide across. It's just that sometimes it makes it harder instead of easier. Here's another example of how to use the strategy that Catherine employed. So let's say that we have 5/8 divided by 3/4. We know that that's really the same thing as 5/8 in our numerator and 3/4 in our denominator, because division is just another way of talking about fractions. So 5/8 over 3/4. Well, if we want to get 1 in the denominator, we just use that reciprocal. Well, what's the reciprocal of 3/4? 4/3. So when we multiply those two reciprocals together, we're going to get 1 in the denominator. Then we just multiply across it within our numerator. That's going to give us 20/24. And now that we have it over 1, we don't have to write the 1 on the bottom anymore. We can just write 20/24. Now 20/24 can be simplified, and that's what's been done right here, 5/6. So we can use Catherine's strategy to do division as well. There's lots of ways to divide fraction. The important thing is that you choose the way to divide fractions that make sense to you, and you use that way consistently, while understanding that there's more than one way to Walmart. So now that you know a lot of different ways to get to Walmart, and what I mean by that is you know a lot of different ways to divide fractions, you can use any method that you want to determine these quotients. I'm just going to review the most basic method that we have used. The most straightforward basic method that we have used is 9/10 times the reciprocal of the divisor. So we just inverted the divisor there from 1/3 to 3/1 and multiplied. That's the most straightforward strategy for dividing fractions. You're also welcome to divide across. That's going to work really well for some of these, and for some of these it's going to be more complicated. It's up to you, but your task for the next 10 minutes is to complete these 6 exercises: A, B, C, D, E, and F. You may work on your own for this. We're going to set a timer for 12 minutes. And at the end of 12 minutes, we'll begin a group activity. So set the timer, pause the video, and do some fraction division. Excellent work. I want to give you a minute just to check your answers because the purpose in this exercise was for you to confirm your own understanding of this concept. This skill is a skill in which we need mastery. We need to be confident multiplying fractions. We need to be confident dividing fractions. So take a minute and assess what you know and try to figure out which questions you might still have because you'll have the opportunity to ask them today. So the last thing that we have today is a group activity. It's called Going Almost Numberless. And there's a variety of questions here for you to discuss. So we're going to look back at dividends, divisors, and quotients in the lesson and just make some generalizations about them. Your challenge here is to complete these sentences using the words greater than, less than, or same as. So you're going to put one of those words in each of those blanks. Talk about it as a group. Decide what you think. Debate it. Do you agree? There is a right answer. You can figure it out. Let's review really quick the difference between a dividend, a divisor, and a quotient. If I said 8 divided by 4 equals 2, 8 is my dividend, 4 is my divisor, and 2 is my quotient. You will need to know that vocabulary to answer question number 1. Now on question number 2, on this one, you're going to work with your group and you're going to answer always, sometimes, or never. Those are the words that are going to go in those blanks. This should be a great discussion. Good luck. Pause the video and set a timer for 15 minutes.